Okay, so since we have our components ready and connected to the breadboard, let's just go ahead and launch our Arduino IDEs. So we can start our sketch. Okay, so the Arduino program is called a sketch, and it provides us with two functions, the setup and the loop. So the setup is where we define what our pins are, whether they're input, whether they're output. Our loop is where we write our main code. So since I already have code, I just go ahead and paste it and then go through. So yeah, okay. So to begin, because we're working with the motor driver, we have the stepper.h. Okay, it's a library that we're using to control our motor. Now, the motor that we're using, the 4-step motor, it has a maximum steps per revolution of 32, and it has a gear reduction of 64. We have to define our steps per output revolution. That states that for a 360-degree turn, it requires the steps per revolution times the gear reduction. That is the number of steps per 360-degree turn. Then we should have our steps required. So that is what we use to tell our motor how much to turn. For our switch pin, that's our push button connected to pin 7. So we have to define that so we can use it in our code. Then 3 boolean variables, all set to low. So the current and the last keep the state of our push buttons, the current state and the previous state, which is the last state. And its open is to check the state of our motor. So say it's turning, then it's high. It's not, then it's low. We'll use the stepper library to define our inputs. Okay, so the as like just like any object-oriented language, we call the class stepper and create an object of the class. Now for the it has a constructor that accepts the steps per revolution. It accepts that because it has to know whether it's a 4-step, 8-step, whatever. So it has to set the steps per revolution and the pins in the order of in 1, in 2, in 3, in 4 on the driver board right here. Okay, in 1, in 2, in 3, and 4. In 1 is 8, 2 is 9, all the way till 11. So we have to write that in that order. Now in our setup, as I said, the pin mode is defined and our push button is an input. So we define that using the pin mode function. I have this debounce button here that I use in any project that uses a push button. So what happens is that when you push a button immediately, there's this moment of instability where the state shakes a bit before becoming stable. So we just stay like 5 microseconds. So in 5 microseconds, everything, all the instability should have died off. So we delay it by 5 so that after that we can get a stable reading. All we're saying is that when we press it immediately, it's high. So we have a digital read, right? It gets the current state of the switch pin, fixes that to current. So we check if our current state as defined as a global variable is not equal to the in last. So the last state is low for now initially. So when we bring the last state in and we digitally read, we realize that it's same as our current. So we don't delay anything. We just return that, which is our current state, which is low. But if our current state is high, it compares it to the previous state, the last state. And if they're different, then it delays it by 5. Then it reads again to get the right reading. To move on to our code, this is our garage function, which is the function that we use to move our motor. So assuming it's a garage door, we have to set our steps per output revolution. This is the number of steps for a 360-degree turn. So we multiply that by a factor, okay, so that we can move in the opposite direction or the positive direction or even a 720-degree turn. So we set our speed to 1000 Then we use the step function, moves the motor. So the step function is what actually activates the motor to move. We want to know if the motor is working or not. If it's moving and it was off before, it will delay for 10 seconds. Then we delay just for 5 seconds so that we can have a moment of stability, so also we can perform our next function. So in our main function, we call it the bounce on the last button. So it checks low and checks the current state and realize that it's the same, so it does nothing. But if it's different, it will recheck to get the correct one. Okay, so if our current state is high and our previous state was low and our motor is not moving, then move in a clockwise direction by two 360-degree turns. Then change the current state to high. Immediately after this runs, it realizes that the current state is still high and the last state is low. It does a counterclockwise turn, which is also twice, so back to its initial state, and then switches this back. Okay, so since we have a code, we should we would have to save. Let's just keep the default naming. And yeah, so we'll now connect our Arduino and then upload. Good.